Hello and welcome back to the Data Unite channel. Today we are going to understand how to implement the support vector classifier machine learning model on a real-world dataset where we are interested to predict whether a person will open a bank account if the bank targets that person during its marketing campaign. I have already imported the necessary frameworks that we are going to use for this exercise, and those who are necessary for us are pandas, preprocessing from sklearn, then standard scaler also from sklearn preprocessing, then train and test split, which is used for splitting the dataset, importing the support vector classifier, and at the end the metrics. So we will just import the classification report. So the first step for us is to read the dataset. Our dataset is gonna be the same that we used before for the classification problems, such as for logistic regression, which is the banking dataset. So we're gonna have dataset pd.read csv banking, and this dataset has a separator which is semicolon, and then we want to see the first 5 rows. As we can see, we have some numerical and some string, which are categorical most of the cases, and our dependent variable is y, so this epsilon, which if we see value 1, that means that the customer opened the bank account, and 0 means that the customer did not open the bank account. Now let's see the dimensions of our dataset. For that we use the shape function on the dataset, and also let's see the columns. Okay, so we have all these columns here. These are all the independent, and this one is the dependent. Now we need to do some sort of pre-processing. So let's just make a chapter here. It's gonna be data pre-processing. And first let's check if there are some null values. So first check if there are some null values. Dataset is null, is not some. Okay, so we can see that there are no null values in any of the columns that we have in our dataset, which is good. Now let's see if we have some duplicate rows, and for that we are using dataset. Okay, let's do it like this. Check for duplicates. Dataset dot duplicates, duplicated, any. Okay, this means that we have some duplicate rows, and we are going now to drop them. So we do dataset drop duplicates. So before our shape was 41,188 rows. Now we have 41,176. So we dropped 12 rows, which were duplicates. It's good practice also to check the type of the columns, and for that we are gonna use the info function. So as we can see, we have some integer and some object, and also we have some float data types of our columns. In our case, since we are using SVM, SVM is asking for numerical values, and for that it's important for us all of these object features that have string values or categorical values to be changed into numerical values. And for that, first we need to do some sort of encoding. In order to do this encoding, first we need to split the categorical from the numerical features. This is a step that I'm doing like this because it makes my work cleaner, but you can also have your own approach that you feel comfortable with. So I'm gonna put a comment, split categorical from numerical features. Okay, so the numerical features are gonna be select the types, and we are gonna exclude all that are with the type object. Equals object. And categorical is gonna be the opposite of this, so it's gonna be including all the object features. So it's gonna be include. Okay, perfect. We are gonna check our features. Okay, so categorical, numerical, and categorical. Let's see if all of them are like that, because maybe you have excluded some feature from one dataset. That, for example, here we might have missed something that is categorical that should be here, so then it would make problems for us. This way we can see that all of the features are split correctly, so we have all the categorical down below and all the numerical above. Now we will perform our encoding, and for that we need to create our encoder first. So I'm gonna use the label encoder because I want to avoid having many features, so explosion of features, because as we can see, we have many different values in all of these features, and if we use one hot encoding, it will create for each value into our rows a feature or a column. Label encoding will just assign a number to each value. So we have pre-processing label encoder, and I'm gonna name the output data frame as label encoded categorical. Okay, categorical, apply, and inside we have label encoder, so LE with transform. Okay, now let's see our encoded features. Okay, so previously we had this data frame, now we have this data frame, so we have numerical values for all of them. So for example, housing, yes, has a number 2 and no has number 0. Now we need to concatenate our new encoded categorical features with the numerical features that we excluded before. So in order to do that, we are going to create a data frame called df, and I'm going to use the concat function. So I'm going to use numerical first, and label encoded categorical is going to be second. And this is going to be done on axis 1, which means concatenate column wise. Okay, let's print also the head. Okay, we have all numerical values. Perfect. Now let's split our features. So basically we want to split our features from dependent from independent, meaning that we want X to contain all the features from that we're gonna use to predict or to classify the value into our dependent features. So X is gonna be just dropping Y from the dataset, and Y is gonna be data frame dot Y. Perfect. Now let's see. Okay, and also let's see the columns. So we don't have Y, epsilon, which is good. Okay, now let me just assign this to a variable. I'm gonna need it later because I'm also gonna perform a normalizing. So normalize. Because SVM is looking for this step in order to perform the categorization into the best way possible. Since we have values which are from different range, we want to make them into the range closer to 0. So basically from -1 to 1 or from 0 to 1 would be the best. So this is why we will use the normalization step. And by normalization means that I'm gonna just use the standard scalar method that is present into sklearn. So let me just define the standard scalar. So scalar equals to standard scalar. Then I'm gonna scale X, all the values in X. So I'm gonna name the data frame X scaled. It. And I'm gonna apply it to X. And then I need to, because this output will be here, this output will be a matrix. So I want to transform it into a data frame. I'm just gonna do this other step. So it's gonna be just take the X scaled and transform matrix and transform it into a data frame with these specific column names. That's why I saved my columns into these variable calls. So data frame X scaled and columns are calls. And now let's see. Come on. Our new normalized data set. Okay, so as we can see here, for example, into cons price index, we have values that are normalized and which are smaller. We want to avoid big numbers because SVM has this strange behavior that if all the values that are present in the dataset are not in the same range, then it would not be able to perform its classification correctly. So this way, all the values have been put into the same range. The standard scaler does not do it column by column, but it does it on the whole dataset. So it takes all the values and then creates a unique range for all of them, and then puts all of these values into that range. Okay, having done this, now we can continue with the creation of our model. So we prepared our dataset, and now we can use it to make our classification prediction. For that, we have our first step is to split the datasets, so basically X and Y, to split them into training and testing. We do that the following way. Train, test size is gonna be 30%, and random sample is gonna be 100. Good. Okay, X is not defined, yeah, because it's should be capital letter. Oops. Come on. Train to split. Random. Random state. Random state. Good. And now let's define our model. So define model is model equals to SVC, which is support vector classifier, and let's fit our model to our training dataset. X train, Y train. Okay, it's gonna do its work. Okay, once we see this message, this means that our model has been created and also trained. And now let's make our prediction. So make a prediction using the X underscore test dataset. So we're gonna save that result into ypred, and I'm gonna use the model.predict function, where I'm gonna pass the xtest dataset, and I'm gonna do the prediction. Okay, with that done, we need to check if our model has good performance, meaning that if the accuracy of our model is good enough for our purposes. For that, let's print our accuracy, for example. Of SVC model. I'm gonna use this format, so I'm gonna use .2f format model score x test or test. Okay, so our accuracy for our model using the SVC on our dataset is 90%, which is not bad. So there would be also some hyperparameters that should be tuned for our model to perform better, but 90% is, let's say, solid as for first deployment of the model. Then on every iteration you will increase the precision, and also you will increase the complexity of the model so that it will have better performance. Let's see also our classification matrix, basically our classification report that shows us all the other metrics such as precision, recall, or F1 score. And for that we will do the following way. Print classification report, and we're gonna pass the Y test and the Y predicted that we had created before. Okay, so from the classification report we can see that our model has a very good performance, or quite good performance, in predicting the class 0, but it has only 65% precision when predicting the class 1. So this means that maybe we have also some imbalance into our dataset. We have less records for class 1 and more records for class 0 while we were training the dataset, the model. So this might be also a good way to understand and go back and understand our data. Maybe we can also implement some cross-validation solutions so that we can overcome this issue. And we'll see also these ways of solving these problems in the next videos, when I'm gonna implement also some hyperparameter tuning and also implementing of cross-validation, which means basically taking random samples, not taking like 70%, but just taking random samples with different sizes, and then training the model on those samples that we have taken during the iterations, basically. So with this, we have implemented the SVC model on a real dataset. And as you can see, it is not that complicated. It is just important to know how to prepare the dataset so that it can be used by the model, and at the end to understand and interpret the results. So thank you very much for following this video until the end, and I hope you liked it. See you in the next one. Bye bye.